Hello everybody, welcome back to my channel, and this video is on the sine rule. So here we have the equations for the sine rule, and this one says for finding an unknown side. So the equation for finding an unknown side is a over sine a. When we have a capital letter here, that's our angle. So capital is equal to the angle, and a lowercase letter is a side length. So up here what we're saying is to find a side, we do the side length divided by sine of the angle, and that's going to be equal on all of our sides and angles that we do. And to find an unknown angle, we just flip all the fractions. So if you see here, the sine's on the bottom, and on this one to find an angle, the sine's then on the top. So here we then have our triangle that the A's and B's are talking about. So you see if this angle is labelled A here, opposite to that, the side length is going to be A. So if we have A over sine A is equal to B over sine B, and we want to find this one here, what we're going to take is this angle here, put that in where it says A, this angle here, put that in where it says B, and this length here and put that in where it says B, and by rearranging we'll be able to find out what A is. Here we have our first problem, and it says calculate angle x. Now because it says angle up here, we know we're going to use our second of the two equations, so that's going to be sine A over A is equal to sine B divided by B. If we label up our triangle like on the slide before, our angle A will put as x, which means the opposite one to it needs to be our lowercase a. Meaning this one here, 95, we can label that as B. So the opposite one to it is lowercase b, and the same with this last one, that would be c. So opposite it, we'd have lowercase c. Now if we put that back into our equation, angle A is x. So if we put that on the top, sine x, because that's all we do, substitute it in, divided by lowercase a, which we've labelled as 12, is equal to sine b, and we've labelled 95 as b, divided by lowercase b, which is 24. Now if we rearrange that to get sine x on its own, all we need to do is times by 12. So if we times that by 12, we're going to be left with sine x is equal to sine 95 over 24 times by 12. Now to get x on its own, we do inverse sine, and that's the button on your calculator that looks like sine minus 1. So if we do that, we're going to be left with x on its own is equal to inverse sine, because you need to type that in first, sine 95 divided by 24 times by 12. And if we type that in on a calculator, for x is going to be 29.87420.126 degrees, which you can round to three significant figures of 29.9. So that is how you work out the angle x. Here we have our second problem, and it says calculate length x. So because it says length, we know that's a side. So we're going to use our first of the two equations, which was a over sine a is equal to b over sine b. So if we label up our sides like we did before, if we're going to call this angle capital A, the one opposite it can be lowercase a, this one b, the one opposite it can be lowercase b, and this one c, the one opposite it can be lowercase c. So if we now substitute in what we've got, we've said side A is x, so if we put that on the top, divided by sine capital A, which is 50, is equal to b, well we said that was 7.2, divided by sine uppercase B, which we said was 72. So just like before, we need to rearrange, but this time we can simply just times by sine 50 to get x on its own. So that's going to give us x is equal to 7.5 over sine 72 times by sine 50. And now when you're typing this in on a calculator, you need to make sure you close your brackets at the end of sine, like I've done here, or it will come out up with a syntax error. So if we put that in on a calculator, x is equal to 6.041000 955, which we can round to three significant figures as 6.04. Thank you so much for watching this video. Please be sure to like and subscribe and comment down below any video ideas that I could make to help you guys out. Also be sure to check out my social medias, which are all in the description box below.